Assalamualaikum everyone. Now today we are going to study lab number 8, introduction and implementation of analog to digital ADC on atmosphere and implementation digital thermometer using LCD LM35 sensor and temperature sensor and battery. Objective of this lab is to understand analog and digital conversion to implement analog to digital converter using LM35 temperature sensor. So we have Arduino Uno, Arduino Mega, and AVR Atmel Proteus LM35 sensor. So introduction is lab and ADC is very useful feature that converts analog voltage to pin and to digital number. And analog to digital converter ADC is a very useful feature that converts an analog voltage to on a pin to a digital number. ADC is greatly between microcontroller and Arduino 10-bit ADC means it has the ability to detect 1024 10 discrete analog levels. Some microcontrollers have 8-bit ADCs, which is 256 level, and some have 16-bit ADCs, which are 65536 discrete level. The microcontroller monitors the number of clock cycles before the capacitor discharge. The number of cycles is the number returned once the ADC is complete. The ADC has two fundamental operation mode: single conversion and free running. So registers the interface of the ADC module for software is through group register. The description below are very brief and only cover some of function of register. For full description, see at my data sheet. This is ADMux multiplexer selection register and ADMux bit 7 ratio 6, which is RFS1 and RFS0. Control the selection of the high frequency, high reference source. So when both are 0, ARF is selected. When both RFS10, RFS01, AVCC will be selected, and when both will be 1, internal voltage 1.1. The ADLAR bit determines whether the left adjust the result or right adjust. ADLR 0 right adjust and ADR 1 so left adjust 8. The mux 3 through mux 0 bit control selection of which 6 input line characteristic circuit. So it is mux into input ADC module. ADCH and ADCL that is high and low bytes and is ADCL with high bit and stored upper byte and so lower bit 8 bit into stored in lower byte or variable. Software ATML and Proteus simulation and RFSG have been elaborated earlier. So the task one is write a program that reads the sensor and display it on port B. So we have included AVR library and it main void. Port B is 0 cross FF and this is output port and this is input port and ADSRA is 0 cross 87 and clock is making ADC enable and select clock divided by 128. ADMux is equal to C0 VREF and ADC 0 right justified. So it is for ADMux so right justified while one is loop start ADSRA. This is for the start conversion and this is for wait for the end of conversion. When conversion is done, ADSR will clear the flag is equal to 1 less than ADIF and port B will be stored the value which will be temperature of the voltage. In this whole example, we have find and then let's see the protein simulation and which shows temperature 37 and we have ADC here. Another interior circuit that's giving you the mid temperature, critical output proven through OC. So this is the code, which is port D is output and port F is output and input, port F is output and port B and C are output. So we have calculated to calculate that temperature in Celsius, and this is conversion for Celsius and ADC to, and then it will be print its value on LCD. So it is a calculation for the simulation. So header file is here, we have elaborated earlier. And so it is the hardware implementation temperature is showing 20. So in this lab, we have learned about detail about the different aspects of ADC and sensor, the displays and coding using Arduino, their practical application and infinity resources and work they have ability to perform.